Hello, welcome back to Learning with Ms. H. Today we're going to be doing Earth science, and we're going to be taking a look at our sun. So a couple things for you to note. Bell work today is to go into your notebooks and just talk about what an HR diagram is for. So write down what you've learned about HR diagrams, why we use them, how we use them, what are they for. And you might also think about how our sun fits into the HR diagram, just to have that connection with today. There's a couple things you're going to do. So before you pause the video, you're going to need to have something to write with, something to write on to take notes. And then while you're out getting that, go ahead and do your bell work in your notebook and then come back. Okay, welcome back. We're going to go through these notes over the sun. And then the last thing you're going to do is these two assignments here. Again, these are very short quizzes. They should not take you super long. And remember that these are not technically quizzes, they're online worksheets, so you can take them as many times as you need to get 100%. That's what you're going to do after the notes. So we are going to talk about the sun, which is our star. It's a pretty common star. It's average main sequence star. Our sun is called a yellow dwarf, and the diameter, so from edge to edge straight through the middle, is the same width as about 109 Earths lined up side to side. So it's 865,000 miles from one edge to the other. It is made up of the same gases as any other star, hydrogen that fuses together to form helium. Remember, when you're doing these notes, anytime you need to pause the video to finish a slide, it's totally fine. Go ahead and do that, and then just restart the video when you're ready. So the parts of the sun, the components, the layers of the sun are like any other star that you're going to encounter out in space. We've got our core, that's the very middle here, followed by a radiative zone around it, and then a convective zone around that. Then you have a photosphere, a chromosphere, and then the corona. So the photosphere is this little area right here. The chromosphere is on top of that, and then the corona is all of this light that escapes here. I would try to have a diagram similar to this in your notes. So the core of the sun is where nuclear fusion happens. It's where all the energy is generated. Huge amounts of gravity right there as hydrogen bonds together, fuses and forms helium. It's about 28 million degrees Fahrenheit, 150 times more dense than water, and the core is 10% of the mass of the sun. The radiation zone in our sun, the radiative zone, whichever way you want to say it, this is where energy is transported by electromagnetic radiation out from the core towards the surface of the sun. It has gamma rays and X-rays in this area, and it's so dense that the light energy actually takes 10,000 years to radiate out of this layer. The next one is the convection zone. Convection is transporting energy out away from the core again. Convection, remember, is like a conveyor belt at the grocery store. It comes up, moves across, goes down, comes back. It's like a little loop. And those transfer energy to the surface, just very similar to watching water boil. All of these convection cells are what give the surface there a little bit of a granular look on the photosphere. So all of these dark patches that make it look kind of granular, those are all convection cells coming up. So the photosphere is what gives off most of the light that we see. It's the surface of the sun. It's about 300 miles thick. It looks very grainy because of all those convection cells coming up on it. Chromospheres, those are the hot gases that are erupting from the surface of the photosphere. It's usually only visible during a solar eclipse, and it's that ring around it. So that really bright ring around the rim of the sun. It has things like solar flares coming off of it and those kinds of things. But all of this bright color around the edge of that black disk, that is the chromosphere. The reason it's visible during an eclipse, the solar eclipse blocks out most of the sunlight. Typically when we have full sun, all of this stuff is blocked out because there's so much light emitted from the other layers of the sun. Lastly, you have the corona. This is the outer portion. It's the part when you draw the sun and you draw the rays coming off. That's what you're drawing, is the corona. It's mostly ionized gases, and these produce our solar winds. They're extremely hot at 10,000 degrees Fahrenheit. Sunspots. These are the dark blemishes on the sun's surface. So all these little spots that almost look like zits, those are all sunspots. The first one was discovered in 1610. They're produced by variations in the magnetic field. These areas are super magnetic. They generally have 11-year cycles between when they show up, disappear, show up again. They've got an 11-year life cycle. So you'll have a super magnetic area here, then it will go away. It may appear somewhere again. These are often going to give us very dangerous explosions that come off of the surface, such as prominences. So all of these offshoots coming from the surface, these archways, this one's kind of a cool little ribbon kind of shape to it. They're all kinds. This one's straight out. All kinds of different shapes, but these prominences are basically these archways of gas that come off the surface, and they're going to shoot up, and eventually they're going to get sucked back down by the gravity, and they follow the magnetic lines of the sun. So you'll see them go off and then come back down, and you can kind of see the magnetic flow of the sun by looking at these prominences. So here's a rendering of a comparison of size of the sun versus the Earth. Again, this is not an image, it is a rendering. You have the gigantic sun here with a huge prominence coming off. You've got some sunspots going on down here, and then you have this little teeny tiny Earth right here underneath the words. So you can see how much larger the prominences are even than our planet. Solar flares. Solar flares are going to shoot out from the sun, and they're the explosive events that come from the sunspots. Super short in length, they don't last very long, but they do get rid of lots of energy. They expel lots of energy out into space. Solar flares can affect our electronics and satellites when they get near us. As that material gets ejected from the sun, it moves through space. If it meets us in our orbit, we can have issues with electronic devices when that happens. They have very high heat and radiation, so if a solar flare were to get in through our atmosphere, it would be super bad for humans. Our magnetic field protects us from those solar flares reaching the surface. And then charged particles such as these solar winds, solar flares, hitting our magnetic field are what cause the auroras. They can happen in the northern hemisphere or the southern hemisphere. If it's the north, it's called aurora borealis. If it's in the south, it is aurora australis. And these are some images of the auroras occurring. Typically, you have to be in the extreme north or south to see them. Occasionally, it's clear enough and they are strong enough that you can see them further down into northern North America. There have been a handful of times they've made it down into middle America, Kansas City, St. Louis, the state of Kansas, that area. It doesn't happen very often. They're not very strong, and they're usually right on the horizon. So with all of the buildings we have in the area, you still can't see them. This is it for the notes. So your next task is to come down here and get started on these 2 homework assignments, and then you're done for the day. We'll see you next time.